Hello, everyone, and thank you for coming to my talk about mobile game development with Platform Preview. My name is Florin Pascu, and I'm a senior mobile engine programmer at Epic Games. So let's start with some introductions. Like I mentioned, I'm a senior programmer at Epic. I'm in the mobile engine team. I've been at Epic for around 6 years now, all in the mobile engine team. And I have 11 years of experience and overall in the gaming industry, shipping and supporting AAA titles on both mobile and console. And at heart, I'm a render programmer. I like everything about graphics, features, all that stuff on both mobile and console. And yeah, if you want, we can talk about that after the session. We're going to go a bit through the agenda. First, we're going to talk about the platform preview goals. These are 3 pillars which we use to guide the development, and we strive to achieve them. Then we're going to go through how the mobile platform preview works. There might be some information you're already accustomed to, some new information, hopefully, and also going to have 2 examples of how it can be useful to your day-to-day debugging and hopefully make your lives easier. Then we're going to go to recent usability and accuracy improvement in 5.6 and 5.7. These are some new features that let you have a more exact preview and hopefully save you the hassle of cooking, packaging, and deploying to device and debugging on Android. Yeah. And future improvements, stuff we want to do for 5.8 and beyond. Some are more near-term than others, but we're going to go through them. And of course, a Q&A session at the end. So let's go with the platform preview goals. I'm going to present them one by one, then show you an example of why these are useful and why you might want to preview instead of deploying to device. So the first goal is what you see is what you would get on device. So we want to offer you a way of seeing how material actually looks like on device without actually having to cook, package, and deploy to your device. We know how much time consuming this is on Android and on other consoles. So if you could just switch preview and see all the issues, that will save you a lot of time and also see the scalability features that are enabled and just help you debug much faster. So on this example, on the left side of the slide, you're going to see the SM6 editor. This is your main editor when you open it in Windows or on Mac or on Linux. And on the right side, we have Android Vulkan High preview, which is kind of what you would see on a high-end Android device for this project in question, which is Fortnite. You would notice the first thing that the shadows are missing. Distance field shadows are not present. That's because distance field is not enabled in Android Vulkan. The tree canopy, you see there's much less detail in Android Vulkan than it is on the editor. There's a lack of nanite, lumen. The view distance is also different. You see the house in the right middle part on both images in the far view. It's actually not, it's actually not rendered for the Android Vulkan preview. Missing grass, which is not that obvious, I guess, but if you look closely, you see that the missing grass blades, there's missing grass blades on Android Vulkan High. And lower fidelity clouds, there's no volumetric cloud, volumetric fog, and stuff like that. So this is very important to see, and you see this without cooking, without packaging. You just switch preview, and you will see these issues that could actually influence the artistic direction you want your project to follow. So this is very useful, I think, for artists or designers. A fast way to debug. So again, we want to save you the hassle of cooking, packaging, and deploying. And this is more to debug features that are not enabled but might seem as bugs because they affect the gameplay experience. And because we wanted to make it fast, we don't want to only make it fast versus cooking, packaging, and deploying, because that's kind of easy. We want to make it fast to just switch back and forth between SM6 and previews to make you quickly see if something is working or not in the platform you want to target. An example of this, again, on the left side, we this time have Android Vulkan SM5 mobile, and on the right side, we have generic iOS. You see that there's a clear difference in the first two that are using an opacity mask, and they're getting the distance from the distance field. They're not rendering anything. And the last example is distance field. It's using distance field for particle collision. Because distance field is not enabled, there's no collision. So you can imagine how that can affect gameplay. So the only other way you could see this without preview would be to cook, package, and deploy to device. And that would take a long time. So seeing it in preview offers you the opportunity of finding workarounds or fixing this on Android before you actually launch it. And the final goal is high-level performance peak. It's mostly to see if something is even feasible on mobile. It won't replace fine-tuning using the hardware tools, of course, because those are more exact. But you could use features such as shader complexity, wireframe view. For example, if you have a door and the wireframe view is a solid and it has 3 million triangles, it's probably not going to work on Android. You might want to fix that and drop some LODs. And for SaaS streaming, you can see how much you go over your streaming per budget. And it's an approximation, of course, because streaming is not really enabled on an editor, but it offers you just an idea if you can stream in higher level MIPS. And we're also going to work on other features. LOD coloration is coming soon. That way you can see the LODs for ISMs, for example. And again, it's just a high-level view. It's just to quickly see if something could even work, or you need to work on the setup of a mesh or texture and so on mobile. And now we're going to do a recap of how the platform preview works. Again, a lot of information probably is not new to you. Some is just trying to clear up some confusion of how preview platform works. And so what preview platform does, it uses the same data-driven platform settings from the target platform and puts it into the preview platform if the editor supports it. Now, a bit of context with this. I'm going to go into this deeper a bit later, but the data-driven platform info, we take it from the data-driven platform info files that are ini files that are inside the config folder of the platform. So each platform has these settings that are per engine. You cannot modify them per project. And we copy them over and create a new shader platform that's a preview platform, but only for the settings that can be supported on the editor platform. I'm going to go a bit more deep on that later. It uses the same feature level as the target platform. So if you're previewing Android Vulkan ES3.1, you're going to be previewing ES3.1. It's not going to be SM6 with some changes. The scalability is going to be the same as the target platform, so it's going to use Android scalability. So the scalability groups will apply the CVAR that they will apply on Android. And the textual LOD settings, this is new in 5.6 of the target platform, will be applied if the device profile changes those target LOD groups. This is important because some textual LOD groups can have max LOD size or change the resolution so they can appear blurry. Again, we're going to go a bit more in depth with this later. And last but not least, you're going to use the settings under the render sections of the target platform. These are in the ini files that are engine ini for each platform. For Android, for example, it's Android engine ini. These are settings you can change per project. Stuff like mobile shading path, if you want to make it forward or deferred. So these will reflect in the shaders we actually are previewing. And a note on shaders, We actually use the mobile shaders. So if you're previewing mobile, we're going to use the mobile base pass picture shaders. We're not going to use the deferred ones from SM6. So you should see pretty much what you will see on mobile. What preview platform doesn't do is it's not going to use the shader format of the target platform. So if you're previewing, in our case, it was an example, we were running Windows Editor with D3D shader format, and we were previewing generic iOS. We're not going to use shader format Metal. We're going to use D3D and feature level ES31. This limitation also means we cannot replicate some shader format specific issues. Non-previewable CVARs, for example, streaming pool size is a non-previewable CVARs, but there are others. These, of course, we won't be able to preview. They're explicitly disabled for different reasons. And this might be a bit obvious, but hardware and driver-specific issues we cannot replicate. If a mobile or console driver is misbehaving for some reason, we cannot preview that in the preview platform. And it does not allow multiple preview platforms to be enabled at the same time in different windows yet. We are working in the future to make this work, which you can imagine can save time if you could have multiple shader platforms at the multiple windows and see the changes in real time. But currently, that's not working. The preview platform is a binary. You have one preview platform enabled, and then you go back to the editor platform and so on. And go a bit more deep into the internals. So as I mentioned, some features cannot be enabled because of hardware support, or lack of hardware support, actually. Lumen, Nanite, inline ray tracing. If, for example, you're launching your editor in D3D with SM5, you won't be able to preview Nanite. But that's just a limitation. And what we do is we copy over the target platform's data-driven shader platform info from the ini files, and then we patch them with what the editor supports. And that's happening in the data-driven shader platform info.cpp and the update preview platforms function. So what we do is all the settings that are not compatible with your current editor platform, we just override them. Think of things like Tile GPU for Android Vulkan. You're not going to be on Tile GPU when you're in editor, so we set that to false. So there are some differences, but hopefully not enough to change the result that much. So the preview platforms are created at RHI init from target platforms, like I mentioned. You only need the ini files from the platform. So what I mentioned, data-driven platform info ini files, the engine ini file where you have the render settings. And you also need the target platform settings, which of that platform, but that doesn't require you to actually have the SDK. Before, that wasn't the case because the target platform was one unitary module. We refactored that in 5.6 into two modules, target platform settings and target platform controls. The target platform settings is the only one you need. So this is important because you aren't required to have the SDK installed on all devices if you want to preview a certain console. You can just have this ini files, have this module in your solution, and it should just work. Shader platforms are defined globally by the engine, like I mentioned before, and they cannot be modified by your project unless you modify the engine. But preview platforms are not like that. Preview platforms are generated from the shader platforms, but nothing's stopping you from creating more. You might need that because by default, preview platforms hard-code the device profile. So we set the device profile, but your device profile might be different on certain console or on Windows, on ES31, for example, and you want to create a different preview platform. That's very easy. You just need to create a data-driven platform ini file inside the configured platform in your project. So if you just create that file and you define the preview platform, it should just appear as a preview platform in the editor. And as an example, so let's say we want to define a new preview platform for Windows D3D S31 because we want to use a different device profile. Let's say we want different scalability groups, different features than the default one. You just create a new data-driven platform info file, like I mentioned, and then you just set the platform name, which is PC, shader format, and shader platform, which these are all defined in the engine. And then you can set your device profile name to Windows test device profile, and you can set it up however you want. And again, this is useful if you're actually launching on Windows and you have a D3D S31, for example, for lower-end Windows machines. You can visualize exactly the CVARs that would be in your game and get a more exact preview. We're going to go how to use the preview platform. So you open the performance and scalability tools submenu in the new viewport toolbar. Previous to 5.6, this was in the settings menu. So you need to be careful that this got moved. So this is the new place you'll find it. You navigate to the preview platform, and you select the preview platform you want to preview. What happens then is a new shader platform that uses the data-driven platform info is created. Like we mentioned, just a recap of before, you grab the new render settings from this ini file, from the platform-specific ini files, and you use the device profile set on the preview platform that by default is hard-coded, but we're going to go over the preview JSON feature that allows you to actually use the device profile selector to select the correct JSON. The RHA remains the same, like I mentioned, also the shader format. So you're previewing Android Vulkan, but you're not in Vulkan. You're in D3D if you launch it in D3D, or in Metal if you're on Mac. So keep that in mind. But the shader code is the same as mobile. So that means that you're not going to use the default code. You're going to use mobile-based path pixel shader, mobile default shading. So it's just going to be with the shader format of UEditor. I'm going to go how this can be useful. So most high-level issues should be previewable, and you should see them in preview. So if anything from this talk, if you see something happening on a lot of the same on all Androids or even different platforms, almost for sure this can be reproducible in previews. So you don't need to do all the cooking, packaging, deploying, debugging on Android Studio and so on. You can just use your Windows tools, RenderDoc, Visual Studio, Unreal Insights to do proper debugging, and should be much faster. So we're going to go over an example, a feature, a bug that happens on multiple devices, a wide range of drivers and hardware vendors. And we're just going to go an example of distance field not working. In this image, we come back to the previous example. On the left side, you see Android Vulkan SM5 preview. And on the right side, you're going to see the Android Vulkan High. We have that same plane that is using the material that has an opacity mask. And you can see how it's working in SM5 on Android, and it's not working on normal Vulkan mobile. And I'm just going to show how you can see what's going on fast. So firstly, we're going to look in the material and see what's going on. We see that the opacity mask has its input distance to nearest surface, but that's with the static switch, distance field rendering switch. And if it's not enabled, then we just input 0. We can go into that switch and see what's going on further. And we're going to see that if mobile distance field is enabled, then the compiler returns yes. If no, then it's a no answer, and we don't support distance field, and we go on the second path. And if we go what is mobile distance field enabled actually checks, we're going to see that it checks the data-driven platform info of that platform. So what that means is that we can go into the definitions in the engine of Android SM5 Vulkan on the left and Android Vulkan on the right. And if we check support distance field, we're going to see that it's true for SM5 Vulkan, but false because by default it's false if it's missing an Android Vulkan. This means that the distance field is disabled on Android Vulkan. So as a result, what you need to do is to modify the material, maybe with a different mask for Android, so you could actually have a proper look. There is nothing you can do to change these shader platforms without modifying the engine because they are set in the engine. But let's go on a second example where you can do something. In this case, we have Android Vulkan SM5 Unreal Fest, which is a preview platform for Unreal Fest. And on the right, we have the editor platform, so SM6 D3D in our case. We see that the distance field shadows, that's the way the level is set up with distance field shadows this close, is missing in SM5 Unreal Fest, but it is present in D3D. And this is kind of strange because if you remember from a couple of slides ago, we had distance field enable, so this should be working. We verify again the shader platform on the left side and confirm that the shader platform is set to true. The distance field is set to true in Android, SM5 Android. Remember that the shader platforms cannot be modified. This means that even if we have a different preview platform, the only thing we actually change is the device profile. So we can identify a CVAR that controls the distance field shadowing, which is r.distance field shadowing, and its scalability CVAR, which means it can be previewable. As a note on that, all scalability CVARs can be previewable by default. You don't need to explicitly set them up. And we can enter the command r.distance field shadowing, which shows us the history of that CVAR and how it was modified. And we can see the history is that the constructor set it to 1, and the set by priority preview set it to 0. Now, I won't go on the set by priority and console variables logic. That probably is another talk altogether. But it's suffice to know that the preview set by is higher priority than constructor. So, and the only way this can be set up as set by priority is if the preview set it up. So that means when you launch Unreal Fest preview, Unreal Fest Vulkan SM5 preview, it set this value to 0. So we're going to check the definition of this preview platform. On the top side, you can see the definition of the preview platform, which we named Vulkan SM5 Unreal Fest. And we can see the device profile name, which is Android Vulkan SM5 _ Unreal Fest, surprisingly. And we go and see what the device profile actually defines. And we see that the CVAR is r.distance field shadowing set to 0. So that explains why when you set the preview up, it set the CVAR was set by preview to 0. Just to confirm that, you can go back to the editor and you type the command to set the CVAR, so r.distance field shadowing 1. And by setting it to 1, you just have shadows again. And this could take you maybe 30 minutes, if that, to just debug and see what's going on, versus you seeing distance field shadowing not working on a project you have, having to make all the APK, deploy the device, see what's going on, probably take you hours. So it just goes to show the speed you can debug issues by using the preview. Now we'll go what preview cannot do. So it cannot help you if you have a bug that happens just on one driver or device combination. That usually is a dead giveaway that's happening because of a driver issue. Another dead giveaway if you have logs and you see a driver error, nothing we can do there. Or error child specific errors. something is happening in Vulkan that makes it unhappy, in D3D is probably fine. So for that kind of things, you need to go back to the old way of doing stuff. And for performance investigations, like I mentioned, if you want to do some fine tuning on your device, you need some 1 milliseconds or 0.5 milliseconds or a couple of megabytes, won't help preview. You need to use the hardware specific tools and go in depth. More examples of driver bugs that we encountered in the wild is barriers not being respected in compute shaders. So you can imagine Niagara is using this to compute their instances. So you end up with a billion particles in Android. Not good. Platform limitations. If there's a mishandling of precision, of mixed precision, that won't happen on 3TD. So if that happens, you need to revert back to the usual debug flow that just gives you the proper tools to go into the hardware-specific issues. Okay, and now we're going to go to improvements that we've done in 5.6 and 5.7 to help you have a more accurate preview of the platforms you're trying to target. Texture the groups preview. So this is new for 5.6. If the device profile you use for your target platform has a different textual LD group, this can affect the way the texture is actually rendered. And we can see the example on the right side. On the top, we have D3D. This is just texture on a plane, and we're zoomed in. And on the bottom, we can see in preview, it's very blurry. This is because the resolution for this particular texture group for this platform was set to 512 or something like that. So this is very important to know as an artist because you can set something up. You set a texture, and maybe it's a map, maybe it's something that's critical to gameplay, and it looks nice in the 3D, but then when you launch it on device, it's all blurry. And the fix for this is usually either modifying the texture group and having greater resolution, or modifying the texture group. Because sometimes the wrong texture group looks fine on D3D or on SM6 platforms, but then when you switch to mobile, when we actually care much more about memory, you get this blurriness. So this is a quick way of saying, like, okay, this doesn't look good on mobile, I need to fix it. Texture streaming pool. We covered a bit before. So this is a way of you seeing how much you are enraged for stat streaming. The streaming pool, so we stream in higher LODs as long as you're in the streaming pool budget, and this helps you keep memory under control, especially on low memory devices like Android or iOS. And before, this wasn't very useful on in the editor because it was pulling all the texture and skeletal mesh editor allocations into the main streaming pool. So you would always be over budget and would not give you any new information. We added a new field that's called the editor require pool that gathers all these material editor, texture editor allocations, so you can just ignore them if you don't care about editor memory. And now the stat streaming pool will actually use the r.streaming pool size value to show you how close you are over your budget. But I won't apply the CVAR because, as we mentioned priorly, this is not a previewable CVAR because the editor doesn't actually use streaming. You always have the higher LODs. So like all the fine tuning advice I've given, if you're near range, like let's say your streaming pool is 500 megabytes and you're like 450, you should still deploy on device to make sure you're in that range. But if your streaming pool size is 500 megs and you're 2 gigs, probably you need to drop something. Preview JSON is a new feature we added. So before we mentioned that the preview platforms have hard-coded device profile. We mentioned that if you want to change the device profile, you create a new preview platform to set a different one. That's fine for consoles because your device profile range is not that big. But for Android, where your range runs from very low end to high end, that's not enough. So for Android, we implemented a way for you to simulate the device profile selector. So the way it works is you generate a JSON file and from your device, and that JSON file is used to run the device profile selector. Your project will actually run by using your project's matched profiles and matching rules, and select the device profile that particular mobile device would use at runtime. As a limitation, because of the way we're selecting Vulkan at runtime, you need to explicitly select the RHI you want to run. So that's why you have in the right picture, you have Vulkan and OpenGL and Vulkan, because we cannot make the same logic we usually do on device in the editor. And like I mentioned, it's only on Android preview for now. And now we're going to go through how to use this feature. So to generate the JSON file, you need to connect your device first. So let's say you have an S10, you connect it to your editor machine, and you go to the same preview platform submenu we went before in the address section, and you select generate platform JSON. This will use ADB commands to gather all the device information that might be useful. It will gather aspect ratio, safe zones, GPU information, and so on that the device profile selector needs in order to select you the right device profile for your game. Then you can select preview via JSON in the same submenu. And you select Vulkan or OpenGL RHI, which one you want to run. And a new window will pop that should be the same window you just saved the generated JSON. And you select the JSON file, and then it's just going to be the preview platform will read that JSON file. It will apply all the matched profile rules that your game uses, and then it's just gonna preview the image, which is not that great now because it has no shadows, but that's how it would look with that device profile. Now we're gonna have a little shout out for UFN users. Before in UFN, you had no way of previewing your console, so the only way you could figure out how it would look was just submitting your content. Now we added a build command that generates generic preview platforms. So these are Gen 8, Gen 9, and portable consoles. They should be in sync with the most common settings that we have across consoles. So for anyone that's developing on UFN, you can use this to see how your content looks on these generic platforms, which should help you make decisions on your project. As I mentioned previous, aspect ratio and safe zone preview is now available. This is new to 5.7. This uses the preview JSON feature, so you need to generate the JSON file beforehand, so we have the information about the aspect ratio and safe zone preview. The editor viewport will use letterboxing on the left, right, or top bottom of the viewport to actually simulate this. This is important again to make you see better how your content will look on on the editor preview, and how it will look in the target platform you're trying to target, like Android, iOS, and so on. So an example you have here is we're using, that's S10, SMG73U. We generated before the JSON file, and then we applied it. The JSON file was read. We read the save zones, and we applied them in the editor viewport. You see left and right, we have letterboxing, but you can also have top and bottom. And the red triangle you see is the way you can disable or enable it. By default, it's enabled, but you can always go into the new editor toolbar and select it, and then it's gone. You notice that the preview JSON worked. You're previewing the Android Adreno 6XX, which that means that the device selector ran on that JSON. It applied the aspect ratio, and it selected the right device profile for this project. Currently, this is QA game, so whatever QA game has rules. But on your project, it would select another device profile depending on the rule set you set. Another nice functionality and quality of life improvements is exposing the preview platform to blueprints. So in 5.7, we added 3 new blueprint nodes that you can use: the disable preview platform, the set preview platform, and the toggle preview platform. The set preview platform has a drop-down that just lists all the preview platforms available currently in your project, and you can select that to just, and it will run the logic that the editor would usually run to select the right preview platform. The disable preview platform, as the name states, it disables them, and the toggle one toggles them. What's nice about these is that you can make blueprint logic with it. You can set it up for automation. If you want a different capture or different setup, you can just make this blueprint and run it, and we'll go through different preview platform, and it should just work. So again, this is useful if you have any kind of automation that might benefit for sanity checking, for example, a certain feature on a preview platform. This can be used. And the more niche feature is the override SP command line argument. This is for people that don't want to enter the editor. If you know the preview platform name, you can just set it up like I did in the last bullet point in the example with -game, -feature level, ES31. And we just set the preview platform, override the max RHA shadow platform. And it's just a nice way of not going through editor indexing and seeing directly how the preview platform works. So yeah, there's not many differences from the editor viewport, but you cannot toggle it, of course, because you're just overwriting the max RHI shader platform that's at runtime. And now we're going to go through future improvements, things we're working on, ideas we have, and yeah. So coming back to the second goal on the first slides, we want the preview platform to be fast. And all components at this moment are being re-registered, and that takes a lot of time, and not a lot of components actually need to do this. And the reason for this is that a lot of them are caching properties because they assume the shader platform doesn't change, which is a nice assumption when you're at runtime, but it's not true when you're in the editor. So we're working to identify these to make this a better system so they don't just re-register all of them. But the problem with that is making the system not brittle, because you can imagine that everyone needs to be aware that when they're making a new component, they need to think about preview. So that's the main challenge in making this possible now. And I mentioned this as a restriction currently, and something we're working on is the multiple editor preview platforms that could be simultaneous on different editor viewports. Like I mentioned, at this moment, you have just a binary, you toggle it on and off, you set the new preview platform, it goes through all the logic. It would be nice if you just have multiple viewports of differentiated platforms, and when you modify a material, it just updates all of them. That could save a bunch of time. But the challenge with that is that it's not really how the engine works right now. So two solutions, tactics are duplicate words or duplicate scene proxies. The duplicate word, I found the engine really doesn't like that. So that's kind of in the backlog. But the duplicate scene proxies is something that we're working on right now. The challenge with that is a bit like the first one in our improvements, that we don't want it easily breakable. And we don't want multiple scene proxies to leak into the runtime. We don't need multiple scene proxies in runtime. We just want one set for that shaded platform. So yeah, both strategies have their positives and advantages, but currently we're targeting the scene proxies, but don't have an ATA for this. It's a bit more in early development. And this is the learning paths if you want to scan this, if you're new to UE, aren't we all, new to programming and new to game design. Yeah.